As we get started on our hammer handle project, it's going to be a little more labor intense than the dice project. I'm going to go over a few dimensions and things that we need to have on our sheet before we get started. Always be mindful of the tolerance box in reference to what tolerances we have on what particular dimensions there are above. I'm going to go ahead and take us to the chart now and look up some of the items we need to do. In all machine shops, they have a decimal equivalence charts hanging up throughout the shop. This is one of the two that we have hanging up in our shop, and the information we need is right here in this location. For drill and tap size is what we need to know as far as the drill size to use for this tap tool we have on our print. As you can see, it says drill 3/8/16, 2.5 inches deep, tap 3/8/16, 1 inch deep, but it doesn't give out the drill size to use. We go to a decimal equivalence chart such as this to look up the information. So if we zoom in on 3/8/16, which is right here, 3/8/16, you can see that it takes a 5/16 drill to make that hole the size we need. So if you scan over here to the decimal equivalence chart looking for the 3/8, the 5/16 drill, and hopefully I'll be able to find it right away. Okay, 5/16 drill right there. It says the decimal equivalence is 3.3125 or 312 thousandths. What we want to do is write that information down on our print right alongside of that. Okay. Now we have wrote down here our 5/16 dimension, which is 312 thousandths. That's the size drill that we need. And also we've wrote up here the 0.625, which is 5/8 of an inch diameter, and that's the diameter that this is going to finish up at. This is one of our standard trainer South Bend lathes we have in the shop. It is pretty forgiving because it's a belt drive machine and it's real friendly to use and operate. I'm going to go over some of the basic components with you right now. This would be the headstock here up above where all the gear mechanism is for the headstock and where the chuck is located right up against it. Okay. This here is our gearbox down here for both metric and imperial threads. It does have a forward and reverse switch and an emergency stop button. As we go along, this is what they call the bed of the lathe. This long thing that goes across here is the bed. This is the carriage. Some people in some training videos call it the saddle. This is a cross slide here that goes across. This is your compound rest and your tool post holder, okay, that'll hold the tooling that goes in. Back here we have our tailstock, and down below we have a drawer that we keep all the necessary wrenches and stuff in to operate the lathe itself. A couple extra drawers below, one being for the tools, students' tools to put their tools in, so their tool bag is not exposed and where they'll trip over it, and storage on the other side for other chucks and different components that'll go into the headstock. I'm going to go over now each particular component of the machine and what its function does. This is the headstock up here. If you open the lid, you kill the power to the machine where the machine now cannot run. Even if you turn a switch on and off, it will not operate. Here, this is the door to open up, and this is the pulley to change from high to low range. So this does the individual speeds across here, and they have a high and a low range. If you disengage the belt, this is spring loaded so the belt comes loose. You can change it from high to low range and move the belt wherever you wish for the desired speed you wish to go. Every time you open the lid or open this door, there are kill switches which kill the power back there, so you cannot get hurt by that being open. The power's cut off at the breaker. Okay, we'll close this back up. We'll close this one back down. Now I'm going to leave this belt not engaged because every once in a while a student will do that, so when I turn on the power, you'll see what happens if that belt's not re-engaged. Just might as well show you now. Okay, this here changes the direction of the lead screw. That's this guy here. This guy here powers the carriage wherever we want, whatever we want to do with it on the power feed. And by whether it's in the up position or the down position or in the neutral position being off, up position turning one way, the switch down, lead screw turning the other way. We arrange this in whatever amount of feed we want to do, or if we're cutting threads, whether it's metric or imperial, which are American threads, we can set this accordingly. We do have a forward and reverse switch and an emergency stop button that we can push in if something goes south. Okay? Now, the breaker, I'm going to re-click the breaker in the on position. The brake power is now back on the machine. Watch when I turn it on what happens. Nothing happens. What it was the belt is not engaged because I didn't push the engagement lever. So now that we push the engagement lever, now the belt is re-engaged. I'll open this up to show you. This belt is re-engaged. We have to go ahead and repower the machine since I opened the door. And now the machine will run this way. Do not put your hand in there to stop this machine. I do wish the machine had a brake. A lot of machines do, where the impatient people can hit the brake and stop the machine, sort of like on the vertical mill, but this does not. Don't be tempted to put your hand in here to stop this machine. This is a finger-braking individual device. If you get your finger in there, it's going to break it really cleanly and nicely. Okay? Now, what this is, we can engage our lead screw, turn it on. You can see our lead screws run in one direction. Turn it off. We can disengage our lead screw and it's in a neutral position. Okay, we wait for that to stop because we don't want to grind the gears. And we can take and put that in the other direction, and now it goes the other way. Okay, in the forward direction, the spindle is spinning towards us, which is mostly the normal direction we would go in order to do turning and cutting on the machine, but it does have the capability of going in reverse. You cannot go in reverse and throw the machine the other direction, because what it will, if you throw the other machine in the other direction, it's just going to continue to run, similar to the vertical mill. Okay, so if we got it going in reverse, shut the machine off, we have to listen for the click. If you listen really closely, you'll hear a click, and then we're allowed, then we can turn it in the other direction. Okay, now we're going to slow this down just a little because it's on wide open down here. We're going to put it right in there. Sometimes if this doesn't want to go in gear, you just spin this a little bit because the teeth are not quite lined up. So if you give this a little turn, then this will go into gear no problem. Okay? Now we're going to move on to the next component. This is our carriage on the machine. Our carriage on the machine, this will crank it this way, and this will crank it that way. It also manually crank this way as well as that way. This will crank this way as well as that way. I've loosened the screws in both sides of this to show you that this can swivel 360 degrees. Okay, we can put it wherever we want it to be. Generally speaking, when we're doing turning operations, it's not a good idea to have it vertical like this. Some people think it is. Some people think it's a good idea to have it like that in their particular machine shops. That's well and good. Me personally, I like it about right there. There's a mathematical formula that if you put it at some sort of an angle right around in this general direction, that changes the ratio of how much you move this, how much that actually goes in. But just for convenience sake, I like it to be right about there. If it's over the top, it gets in the way of what you're doing here. So right about there is nicely to have it there. Okay, I'm going to spin it over here. This is our tool post holder. As we move this handle, you can see this go up and down, and that locks our tooling in place. So if this is over here, and this is locked in place, I'm just going to snug this up for demonstration. And you take this, you can open that up, drop that down, lock that in place, a good snug pull on it, gets it there. This here determines the height of it. Okay, on our machine, we have a particular block that we can use right here. This particular block, we can set the height of the tooling on there as far as from this up to the top, from this distance as South Bend, from here up to there to set the tooling height for center, and the other one is for one of our other machines that we have somewhere else. Okay, now, like I said, we loosen this up. This adjustment can be, when it comes down, it hits the top of there, and that adjusts our height, and then we lock it in place. Okay, now, I'm going to go ahead and make this carriage start to move. We'll fire up our machine. And this is right now is in a neutral, that would be a neutral position. So if we tighten this up, nothing happens. Okay? If we loosen this, we put it in this direction, we lift it up, we tighten this, we can see the carriage is now turning and going in that direction. Now, if we want the carriage to go in the other direction, we would shut the machine off. We would come back over to where our lead screw is, and now we're going to make the lead screw turn in the other direction. Now the lead screws turn in the other direction, and our carriage is going in a different direction. We loosen this up, okay? We loosen this up just a little bit of a turn to make this stop. This thing here grabs a hold of that and then goes this direction and that direction. If you loosen it up all the way, this carriage gets a mind of its own, and we need an exorcist to come in and fix it because it just goes squirrely. Do not loosen this up as far as it'll go and as tight as it'll go. We either snug it up or we make it loose. Okay? But don't try to unscrew it all the way. Some of the machines get a mind of its own, and like I said, it goes anywhere it wants. Okay, this here, that's the neutral position. If we tighten this up, nothing happens. If we put it down in this direction, you can see now it's operating this. If we want this to go in a different direction, we'll shut the machine off. We'll change the direction of the lead screw to there, turn it back on, and now it's going in the other direction. This works. When it's down, it works this. When it's up, it works that. Easy peasy. Okay. Now, as we move along a little further over on the machine, I'm going to zoom in a little. There's this little guy right here. This guy right here, you can swivel it, and this little gear here will go against the lead screw, and there's a little facing dial up here that's got graduations on it, and this engages this. When you lift this up and engage it, then it'll start cutting threads. Whatever we told it to do as far as the speed of this screw down at the end, when this is engaged, this gearbox will turn and go in this direction down like this, and be engaged here in these grooves with this little gear here, and it'll cut whatever thread you wish it to cut. Now I'm going to take it to the tailstock. The tailstock is meant to slide back and forth in and out of your way as you needed to use it. When you want to put it in a place where to use it, you put this wrench on it, yellow handle wrench, and you tighten this screw up, and what this does is this tightens up and draws a plate up on the bottom which locks this in place. Now it can't be moved. I tell the students, and I warn them about this, that when you want to loosen this, you just take this in, and you loosen it up, you turn it about a turn or so, just enough to make that plate go loose on the bottom. It'll slide really nicely back and forth. If you take and loosen this a whole bunch of turns and that plate's down there and gets crooked and you forgot how to swear, that plate gets caught in there, forget about how to swear, it'll all come back to you, because that is a bear to get back up there and in where it needs to be. Okay? So we want to just loosen that a little bit to get this to operate. Now once we got it in place, this here is our drill chuck, okay, that can go with what they call a Morse taper. We clean this out pinky clean, make sure it's clean, wipe this off with our hand, and when this is screwed out a ways, that will stick in. We know we got it in there properly when we can pull our carriage back and forth like so. Okay? Now, when we want to get this out, we just take and crank our handle back here, and as we crank our handle, you can see this will pop out. There's a little bitty piece in the inside of here that pushes on that pops that back out where you can get this release. By the same token, if this is back here, you can't put it in and it won't stay. So you got to bring it up past that point of the little knockout bar, stick it in, and when you can pull it to and fro, you know we have it in properly. This is our chuck key for our drill chuck that we can put in here and tighten or loosen our drill chuck. That goes like so as we go around. This here is a lock. I encourage students not to mess with this, okay? Because there's no real reason why we need to lock this in place on our particular jobs or projects. And if you snug it and lock it up, it can give you a false sense of security on one of the operations where we have to keep a snugness against our center. So it can really do a little bit more harm than good as we're going along until you're totally familiar with the machine and understand the various ins and outs that go along with everyday use of the machine, okay? We also have, in our drawer, we have what they call a live center. Again, we're going to be wiping that off, putting that into the hole, pulling it to make sure it's in place, and we'll be using that through our job as we go along. This is our standard tool drawer, what's in our drawer as we go along. When you open up the drawer, these are the tools you'll find in it. Okay? What we have in the box, like we were spoken a moment ago, is our live center that we will use through various times of our project. They call it a live center because on this end it spins, okay? And it helps steady our work. And then this here goes in our tailstock. We keep it in this little wooden box here. Then as we go along, this is our chuck key, which we'll be using in our chuck, and I'll show you that in a minute. One of the most important things about this is this spring on here. Whatever you do, don't take that spring off. That's bad juju, okay? I've been here 6 years at the school, and I can count on one hand how many times a student has taken this off behind our backs. we use the chuck key without the safety spring and turn the machine on with the chuck key in it. 3 times, okay? And all 3 times we were lucky and fortunate that no one became injured in the incident. The safety spring is on there for the students' protection, and they're encouraged, they're insisted to leave that on there during operation, okay? This is our yellow-handled wrench for the tailstock. This is our chrome wrench, I referred to it as, to tighten up our tool post holder on the machine. We encourage everybody to use the boxed end on it. It's a lot easier to use. Our drill chuck for the lathe. We do have in here, we have a brush. That's for the bed of our lathe, the blue thing, to clean it out with. We have our file card, which we use to clean out our file when it gets dirty, when we're doing our filing operation. And we have a paintbrush to brush away chips. Under no circumstances is the file card to be used for a brush. This is not a brush to be used on a machine, just on the file. In fact, it's a good idea never to rub your fingers or hands or get any oil in this brush whatsoever, because that hurts the use of this. Once you get oil on your file, it does not work as well as it should. It actually does more harm than good. Okay? Now, we also have a file in our drawer at each machine as well, and we have what we refer to as a little cheater bar. It's got a hole drilled into it, and I'll show you as we go along what that's for. Our T-handled Allen wrench, which goes into the side of our, up where our compound rest is, where we can spin it to loosen it, okay? And this little guy here, this little Allen wrench, used to be to lock the carriage, but we just since made a change on our carriages where we have the handle already there to fix that. Second drawer down. This particular drawer is for the students who put their bag of tools in where they can access them and they're not sitting on the floor. Now we're going to go ahead and get started. We're going to go ahead and put our bar in the machine, slide that on in. What I tell the students, stick it out about 2 fingers. And this is our chuck key that goes in the top. As you can see, it's got the spring at the top. That spring's to do one particular thing. When they let go, it's made to fall out on the floor so that they don't leave it in there by accident. If they force the spring off and put it in like this, they can put it in like that. Then they'll turn the machine on, and at 600 RPMs, that comes flying out towards them. Okay, like I said, there's no reason for them to take that spring off. That spring is in there for their safety to stick in there. If they want to snug it up, they can bring it down like this. Make this good and tight, okay? And then they're going to bring their tooling in. Our tooling's at a slight angle like this in order that when we go to cut it, it just cuts with the cutting edge itself and doesn't create any drag. I'm going to go ahead and bring this on up, then reposition the camera. Now I went in and touched the tooling to the work, and you can see we're not on center, we're just a little bit above. So if we were to take this here and double check ourselves, we can see that our tooling is above what they is recommended for the height of where our tooling should be. Now, I can bring it down to that. Another thing is we really don't need that plate. What we can do is we can take and see when we're right on center. We should be able to take and cut this all the way off. I'm going to put a little blue on there. We should be able to cut this all the way off till it goes right down to the center itself. So what we're going to do is we're going to take some cuts off of there. I'm going to go ahead and crank this in a little bit, and I'm going to show you what it looks like, because I want you students to do this all manually. As you can see how that tool is cutting like that and taking that chip off. I'm going to stop it to show you what I'm doing on the other side. It is generally not recommended to shut the machine off with the tooling touching the work, because it'll chip the tooling, but on aluminum it's a lot more forgiving. Now, as the machine's turned on, I'm going to show you what I'm doing with this particular handle here. To make those chips produce there, I'm turning this nice and slowly and consistently to make those chips come up right there on the cutter, as you see, right up here. Now we're going to go ahead and do another cut on the machine, and I'm going to show you what that does. We'll take and bring this on back. I'm going to advance the carriage in that direction just a little bitty bit, just a little, okay? Stop the carriage, and then I'm going to continue to crank this across. What I've done is I've engaged the feed on it so you can see what's happening. That way I can work the camera on the back side. And you can see that as it goes across, if I was cranking the handle, that as we crank it across, it feeds towards the center of the machine. Now this only cuts down to the center, okay? I'm going to shut it off a little earlier to show you this. Right now we're very close to center, okay? I'm going to turn it on and I'm going to feed it manually the rest of the way. Okay, as I feed it across manually, you can see we got down to the center. When we're turning a face like this, anything from the center to the back side does more harm than good. So once the center is gone, you are finished with this. Now, you can see that the finish is really nice across there, and I'm just cranking it back out nice and slowly. But in a lot of cases, the best finishes to get are when it's pushed into the work here just a skosh and a little bit, and you take and you bring it back this way manually. It kind of gives it your best finish. Don't ask me why, it's just that I always found the finishes on the way out are a little nicer than they are on the way in. Now, the one thing that's bad about doing it this way is that drags the burr up. This is like a knife edge right there. So you got to be careful not to put your hand on there and feel that. That will cut you wide open, and you'll want to use one of my good Band-Aids, okay? Because that is sharp right there at that edge. So, what we can do if we want to get rid of that is we can take our file left-handed. Your right hand always touches here, your left hand touches there. We just hit it a little bit, like that. Now it's all clean on that end, ready to go. We're going to be taking and doing some work with our tailstock on the end of this part. So we need to bring this up and make sure that we can spin this manually without running into anything. If you should desire, you can disengage this and take this out of the way, okay? But bring this up, and what we're trying to do is we're trying to clear this drill chuck, make enough room so this drill chuck can fit in here, okay? Now, we've taken the drill chuck out of the drawer, we've cleaned it off, we make sure that the hole in there is, and the taper is pinky clean. We crank this out a little, we engage that. We pull a little bit on this to make sure it's where it's supposed to be. This is a center drill. It's the same on both ends, and it's made so that we can use this particular device in there and support that work. The taper on this is the same as the taper on the top of this. When you want to know how deep to go, there's an illustration on our whiteboard that's on there all the time that says how deep we go is we want to go a certain depth. I'm going to put this up in there. Now we have to tighten this up in there like so. Good and tight. Now we're going to turn our machine on and we're going to begin to use that center drill. As we go into it, we start cranking it nice and slowly in to get a chip like that. And what we're trying to do is crank it to a point where the taper is what we're looking for. Now, as we begin to get closer, let me zoom in on that. Okay. We begin to run up this taper, okay? Now, if we get up to where this taper's edge is, that's going to be too far. So we're going to go a little more. As you can see, I'm bringing it in, okay? Cutting a little more out, okay? I'm going to back it off, get rid of the chip, and change the angle. Now, the viewing angle is a little different on this side. And what we're trying to do is to bring it up where we're just below full diameter. So right about there would be good. Perfect. That's how big around we want it. We want to stop it before it gets all the way up to the top of that taper, because we're going to be actually guided and supported by the taper itself. We're going to go ahead and take our tooling out of the drill chuck, like this. Now, if you need a little help getting this in or out, that's where this little bar comes into play. It's got a hole in it. You can push that over there. You can make this tighter or help to get it unloosened. Okay, you'll take this out of there first. Then you'll take this out of there by cranking the handle back until it pokes it out. We'll put our chuck key back in just for storage. Okay, Now we're going to take and go ahead and put our center in. So we'll clean it off good. Take our pinky, make sure there's no chips in there, bring this out where it sticks, pull it, we're good to go. Now we're ready to turn the 625 diameter. What we want to do is we want to make that 625 diameter to turn that an inch further down than we need so we can put this particular diamond shaped pattern on, or knurl on, from here to where it ends. So what I tell everybody to do, to come around to the back of the machine where we can see it sticking out as the way it would appear if we were on the other side. So what we want to do is we want to take our 10 inches and we want to add an extra inch to the dimension from here to here. So if we just deduct off this inch here and say 4.5 inches, so 4.5 inches from 10, which would give us 5.5 inches from this end to a spot right about there, and then we can turn the 5/8 diameter down, and in turn also run our knurl up past where we need it to stop, so that way we can bring this back up and make a nice clean edge where it ends. So if we come around here and we loosen our chuck and we pull out our material, we can take our scale that we have in our, this is not a ruler, it's a scale. Take our scale that we have out from the into the chuck jaw. We want it to stick it out an inch more than we need. So around 5.5 sticking out is what we're shooting for out here on this. Then we'll tighten this back up good and tight. Okay. We'll go ahead and bring our center up till it touches. Okay. We'll tighten our nut underneath to lock our tailstock in place. Good and tight. Then what we'll do is back here on our tailstock, we'll bring this up and snug this up. Just sort of a good snug like this. Okay? Now, as we come back across to here and we turn our machine on, what we want to see, we put blue marker on this intentionally because we want to see that spinning. At any given time that stops spinning, that's bad juju. That means this is not supported anymore, because whatever we've been doing has been taking this bar and shoving it in there, or this here has been coming out there. Now we're going to take our, turning our diameter up to about there, because we're sticking out an inch more than we need, and if we turn this diameter up to the blue mark to 5/8 on the diameter, that will work out for our knurl that we want to put in. Lock it in place. Take our big shiny chrome wrench. I hold, anytime you push on this, I hold on that, because you can push hard enough on this big wrench to overtake the set screws that are in here and spin this like a top. So if I push on that, I hold on this. If I pull this tight, I push on that. Okay, so push on that. I can loosen, turn this wherever I want it. I'm going to put it about that location. Okay, because what I want to do is turn this diameter down, and I want the nose. There's a little bit of rhyme or reason how you put it in here. It depends on how it's cutting, to the angle you want. Anywhere from here to there is good, okay? Anywhere in between, depending on what kind of finish you're getting up here on the part itself. So we're going to go up to here. We're going to crank this into place. Okay? We're going to come around here. Okay? We're going to turn on our machine. Well, I'm not going to turn it on quite yet. We're going to bring our tooling down here. Okay? We're going to turn on our machine. As soon as we engage our feed, turn on our machine. Now our lead screw down here is turning. You can see it turning. Okay? Now, we're away from our work. We're going to give a little test on our carriage to see if we're going in the right direction. Nope, this is engaged. Bring it up here. You can see that the wheel is turning in the correct direction. It's going this way and bringing our carriage towards our headstock. Okay? So if we go back up to here, we can see what's going on. We're going to come in here till we touch. Now, back over here on the dial, we can loosen this knob and turn this wherever we want. So we're going to take off about that much, just a little bit to get started. Now, if you look up there, you can see the chips coming off as they go. Now, I'm going to shut the feed off. I've made the knob read 0. I'm going to break the knob out, away from the work. And I'm going to check my diameter there to see how big it is. We got our calipers, got them cleaned out, closed, turned on, double check our 0. Now we're going to measure. We're going to measure how big around this is. Now, we can go like this, or we can lay them sideways so that we can look up and see what we've got. And as we look up, I show that to be 701 thousandths. So I'm going to pull it off. You're showing about 703 on there. It was about 701 when I pulled it off. So that's where we're starting, and we're going for 625. Like I said, we measured it. We're at 701 diameter. We're going for 625 diameter. We subtract one from the other. That gives us 76 thousandths of an inch to take off. I brought the carriage back into where we left off on that diameter, okay? So we're going to continue that diameter on down to the finish. Now I've reached my line up there on the machine. I'm going to go ahead and back it out. We left it off on 0 and shut the machine off. Now, something that's very important to tell you. As these chips are coming off the machine, you'll be tempted to put your hand up there and let them run through your hand like this. That's bad juju. Absolutely bad juju. These are like giant little razor blades. And if you were to grab these with a hammer and squeeze them and drag them through your hand, they would just cut your hands to ribbons, okay? I have a personal friend that I went to trade school with. We went to high school together, or trade school together. His little finger is permanently like this, permanently from the age of 18, where a chip off a lathe cut through the tendons in his hands. He was in surgery that evening, and his finger now is permanently stuck like this for the rest of his life, okay? Chips on a lathe can be dangerous as they can be. Now the conditions were different. The lathe was bigger, chips were bigger, but the end result is the same. Those chips will hurt you. Do not grab them with your hands. If you got to learn how to handle these like if you're handling a razor blade. I brought the machine back up to where we left off as far as the 0 mark on the dial, okay? We have cut the whole surface on down from there to there down to our mark, and what we're going to do now is take another pass. We got 76 thousandths to go. The finish is not really acceptable, okay? It's kind of rough. It's not good enough for our knurling job that needs to be done. Like I said, when you're setting the tool up, you can tweak that angle in a little bit to adjust it to compensate for any imperfections of the tooling. Okay? Sometimes the tooling, especially on a light machine like this, can take and influence the carriage feed to sort of hesitate and stutter, which will in turn make a finish similar to this. To compensate for that, we're going to make an adjustment here on the angle of this tooling. We're going to tweak it into this so all the pressure is headed back in this direction. A little more maybe wouldn't hurt. Then we're going to come in, run the tooling in till it scratches. When I see it scratch, okay, then we're going to come back down to our knob down here, where's our knob? Come out wherever you are. Come back to our knob here, okay? And I'm going to loosen our collar and bring it around to 0. Okay, we got 76 thousandths more to go. Each mark on here, each mark on here takes off 2 thousandths of an inch. Probably every lathe you'll run across in your life will only take 1 for 1 in this direction. Very few lathes that I have ever even seen or heard of take off 2, but these lathes are one of them. So each mark takes off 2. So 5 would be 10, 10 would be 20, 15 would be 30. We're going to take off 30 of that 76 more to go, give or take. And we're going to turn our machine off. We're going to come back up to check up here to make sure this is spinning. I'm even going to touch my finger on it a little bit to make sure it's going round and round. And we're going to go ahead down here and we're going to zoom out. And we're going to go ahead and engage our feed and begin the cutting process up there. I'm going to go ahead and shut the feed off. Okay, crank my machine out, crank it back down. Now, on numerous occasions, practically 50% of the time, these chips will get wadded up in this chuck and they'll start spinning around on you. Don't panic, just shut your feed off. Crank your tooling away, shut your machine off, and you can clear them. Now, somebody will say, well, if he would set the speed and feed correctly, there's a chip breaker on, and the chips would break as they come off. Yes and no. There's a lot of conditions that come into play with that in reference to the chip breaker, the type of material you're cutting, whether you have coolant or non-coolant, how depth of cut. There's all kinds of variables. The chips are the chips. You know, sometimes it works well, sometimes it doesn't. Since we're not doing production and making a one-off piece, we can afford to accommodate a little chips not breaking up just like they show in the movies. Turn on our calipers, just run them out, run them in, they're at 0. Let's remeasure to see where we're at. I'm holding them at an angle where I can see. I'm at 665 on the diameter. At 665 on the diameter, if you do the math, we got 40 thousandths more to take off. If we bring our dial back into where we left off, which is 0, we crank it over, we got 40 more to go. 5 takes 10, 10 takes 20, okay, 15 takes 30. We're going to take another 30 off and see how we're doing. Again, we come up here, make sure this is spinning, engage our feed. took the liberty off camera to take another pass or two off the part to give it a nice clean looking finish for our knurling operation, and working with the tolerance that we had available, taking and going to go ahead and measure it. Okay? As we put our calibers on there, the measurement on it is .615 diameter. Was 615 diameter was the diameter of what the bar measured. Nominal dimension was .625. Our nominal dimension was .625. Right now we're at .616 or 616 thousandths on the diameter. Okay? As we go up here, we see that particular dimension was in a fractional dimension. So as we go down here to check the tolerance on fractions, I took the liberty of writing in the decimal equivalents. So on a fraction, we could be plus or minus a 1/16th of an inch and still be correct, or we had up to 62.5 thousandths plus or minus where we were in tolerance. As you can easily see by looking at this, we're well within our tolerance, taking a little extra off, approximately about 10 thousandths off the diameter to give it the better finish that we need for the knurling operation.